Okay, so this is experiment number 10, combined gas law. Please make a note that for this experiment you have a pre-lab and you have a post-lab. If you're my student, you're going to submit everything together, of course. So the whole purpose of this experiment is to measure the change in volume for a sample of air. How is the volume of air affected when you alter the pressure, when you alter the temperature? Okay, so I'll discuss this more in a bit. So in the video that I filmed, I kept mentioning Charles' law. And Charles' law applies only to a fixed amount of gas at a fixed pressure. When you guys have these two conditions, then we can say that the volume and temperature are proportional to one another. So what does that mean? Well, that means that if the temperature increases, the volume increases. If the temperature decreases, the volume decreases as well. So volume and temperature are proportional to one another. So I kept mentioning that often in the video. So in the video, you're going to see a setup similar to figure number 1, where initially, first know that our sample is just air inside the flask. Air inside the Erlenmeyer flask, that's going to be our sample that we're working with. So what I did, I placed this inside a beaker full of boiling water. And this tube here that you see here is actually open to the air. So air molecules are actually escaping out. And air molecules are escaping out because they want to maintain constant pressure. The pressure inside the flask needs to be the same as the pressure outside, and the only way that's going to happen is if some of the air molecules escape. So eventually what I do, I place a pinch clamp there. I close the tube. And as soon as I do that, well, think about it. Is the air inside the Erlenmeyer flask fixed? Is the pressure fixed? So if the amount of air inside the flask is fixed and also the pressure is fixed, then we can apply Charles' law. So what I do next, I move this entire apparatus, I move it into a container full of cold water. And I want you guys to ask the following. What happens if you go from boiling water to cold water? The temperature decreases. What do you expect the volume to do according to Charles' law? If the temperature drops dramatically, what's going to happen to the volume according to Charles' law? So you'll see that in the video. So the whole purpose for today is to measure V2. It's just that we're going to do it 2 different ways. So this here should be V1 first of all. So the whole purpose of today is to actually calculate V2 using the combined gas law. So that's simple because I provide you with P1, T2, T1, P2. You just plug in the values. I provide you with V1. So going back to this, what happens when I remove the pinch clamp right here? Well, if I remove the pinch clamp, water is going to go inside. Now, why do you think water rushes inside? Well, think about it. If the volume drops, it creates a vacuum inside the flask. And as soon as I remove the pinch clamp, water is withdrawn inside. So I'm going to measure that volume of water that's withdrawn inside for you guys. And here, we're going to measure V2 by taking the original volume of the air minus the volume of water that rushes inside. So essentially, the whole purpose for today's lab is to calculate V2 and to also measure V2. And these two values should be quite close to one another. Now in science, you have to quantify everything, so you must calculate what's called the percent difference. Make sure you have the right number of sig figs and right number of decimal places when you do this, please. So in science, you cannot simply say, yeah, well, they look close to one another. I did a good job. You cannot really do that in science. You have to quantify it. So you take V2 calculated minus V2 absorbed divided by V2 calculated times 100%. And you want this percent difference to be very, very small, right? After all, they should be about the same. So the whole purpose of today's experiment is to calculate V2 and to measure V2. And if I did a good job, these two values should be the same. Very low, very small percent difference. Okay, so please enjoy the video. Okay folks, so this is experiment number 10. Experiment number 10. It's the combined gas law. And here I have our sample today is going to be air. The air inside this Erlenmeyer flask is going to be our sample. Okay, this flask is dry, and the air inside again is going to be our sample. Okay, this is an open system because there's a tube here that's connected to a hose, and the hose is open to the air, so it's considered to be an open system. Okay, so what I need to do is measure how much air we have inside, and for that I will do that for you guys. I will add water, fill this with water, and then measure how much water it holds. Okay, so here's the flask. Most of it is submerged under boiling water. It's been sitting there for over 5 minutes. So we're going to assume the temperature of the water equals the temperature of the air inside the flask. And notice it's still open. So this is very important because the system here, the open system, the pressure outside is going to be equal to the pressure inside. The only way that's going to happen if some of the molecules escape through here to maintain equal pressure. But what I'm going to do today, I'm going to place this pinch clamp here, and as soon as I do that, it's going to be a closed system. And by that I mean that the amount of air inside the flask is going to be fixed, and also the pressure inside is going to be fixed. And therefore we can probably use Charles' law to predict what's going to happen. What's going to happen to the volume of the pressure of the air inside the flask if it goes from boiling water all the way to ice cold water? What's going to happen according to Charles' law, right? So what I'm going to do right now, I'm going to place the pinch clamp here. As soon as I do that, I'm going to remove it from the boiling water and place it in cold water here in this container here. Now I already measured T1 for you guys. I already measured T2. T2 is the temperature of the water here. Okay, and I also already measured the barometric pressure using this barometer here. Okay, so let's go ahead and do that. And once I submerge it underwater, I have to leave it there for 5 minutes. And after 5 minutes, I'm going to remove the pinch clamp, and water is going to go inside the flask. And I have to measure how much water goes inside the flask using a graduated cylinder here. Okay, so I'm going to place this here. There you go. We can apply Charles' law here. What's going to happen here if it goes from to the volume of the air inside, if it goes from boiling water to cold water. Okay, so now I have to keep it here submerged for at least 5 minutes. And after 5 minutes, I'm going to remove the pinch clamp, and water is going to go inside. And then I'm going to place the pinch clamp back on. Well, actually, after that, I have to equilibrate the pressure. We want to make sure the pressure inside the flask equals the pressure outside here in the lab. Then I can place the pinch clamp, and then I can remove it. And then I will measure how much water was withdrawn inside. So I'm going to do this. I'm going to do this here. I'm going to leave it here for 5 minutes. Okay, so the flask has been here submerged underwater for about 5 minutes. So now I'm going to remove the pinch clamp. I'm still keeping it submerged. So now, before I remove the flask, I have to make sure the pressure inside the flask is equal to the pressure here in the lab. And by that, I have to make sure the water inside the flask, the level of the water inside the flask is at the same level as the water inside the container here. So now I'm going to place the pinch clamp back on, and now I can remove it. And as you guys can see, some of the water went inside the flask. So I'm going to measure this volume for you guys, okay? And I'm also going to measure the volume of the original sample of air that was inside. And with this, we should be able to do our calculations. Okay, so I hope you guys enjoy the video. This is the data that I collected for you guys, and this is going to allow you to do your calculations. So your task now is to calculate V2 calculated, to calculate V2 absorbed, and then you're going to compare them by calculating the percent difference between them. This is the formula you want to use for the percent difference. This right here is absolute value. Okay, so you're going to follow this formula here to calculate V2 calculated. Make sure you change this to V1. I highlighted it. It's V1. And this is the formula you're going to use to calculate V2 absorbed. Okay, V1 minus delta V absorbed. So you have all the data here. Please note you want to make sure you show your setup. If you're my students, make sure you have the right number of sig figs. And also, very important, don't forget to change degrees Celsius to Kelvin. You must convert degrees Celsius to Kelvin when you do your calculations, please, or else your data will not make any sense. Thank you very much.